A solid cone of diameter 24 centimeter and height that is 20 centimeter float with its vertex downward in water as shown in figure. Is this cone its stable equilibrium? That is specific gravity of solid that is given, that is 0.8. So this is important question for ESC point of view, very important question, and this figure is given in this question. So here this is the free surface is there, and this is the cone, solid cone, okay, and diameter is given, d is 24 centimeter, which is given, that is 24 centimeter, and here to here the distance, consider this is y distance, and here to here this is height of the cone. Now if you want to find out the value of here to here, this will be 3 by 4 into h, so that is equal to 3 by 4 into 20, so 15 centimeter. So O to G, OG, the height is 15 centimeter, okay, and from the free surface to the O, consider the value of y, this is the distance, the height, that is y. So from here to here the distance will be 3 by 4 into y, okay, and consider this diameter here to here, this diameter is small d. Now what is given in this question? So given the diameter, that is capital D, that is 24 centimeter, height that is 20 centimeter, and s that is equal to 0.88. Now so gm, if you want to calculate the gm, that is equal to, we know that gm that is equal to ba minus bg. So for stable equilibrium, gm should be greater than 0. So if you want to calculate the value of tan theta, that is the, so this is, if this is angle theta and this is the total distance, that is 24, so here to here the distance will be 12, and what is the value of height which is given, that is 20 centimeter. So tan theta, that is 12 by 20, that is equal to 3 by 5. Now if you want to calculate the value of here to here, consider this is small d, this is small d. So if you want to calculate the value of d, small d, so here to here the distance is d by 2, so tan theta that is equal to d by 2 by y. So here to here the distance is y, okay. So from here d that is equal to 2y tan theta, that is 2y. What is the value of tan theta? That is 3 by 5. So from here that is equal to 6y by 5. Now let's try to calculate what is the value of y. So to calculate the value of y, we have to do a calculation, that is at equilibrium condition, weight of the solid surface that is equal to buoyancy force. So omega of solid surface into the volume, that is 1/3 into pi into d by 2 square into h. This is the weight of the solid surface, and this is the buoyancy force, that is omega of water into pi by 3 into, so pi by 3 into d by 2 whole cube into y. So from here you can get the value of y, that will be equal to 18.566 centimeter. So you can get from here the value of y and put the value of y in this side. So what is the diameter d? That is 6y by 5. So 6 by 5 into y, that is 18.566. So from here you can get the value of d, that is 22.28 centimeter. Now if you want to calculate the value of bg, so if you want to calculate this value, so bg, so 0 og minus ob, so og minus ob. So what is the value of og? That is 3 by 4 into 20. So what is given in this question? That is 3 by 4 into 20. So 3 by 4 into 20 minus 3 by 4 into 18.566 ob. How to calculate ob? That is 3 by 4 into y. So 3 by 4 into y value, that is 18.566 centimeter. So from here you can get the value of bg, that is equal to 1.08 centimeter. Now if you want to calculate the value of bm, that is I by vfd. So that is equal to pi by 64 d to the power 4 divided by 1/3 pi by 4 d square into y. So from here you get the value of bm, that is equal to 5.012 centimeter, okay. So from here if you want to calculate the gm, we know that gm that is equal to bm minus bg. So what is the value of bm? That is 5.012, and what is the value of bg? That is 1.02 so centimeter. So from here you can get the value of gm, that will be 3.932 centimeter. So this is the positive value are there, so that's why it is in stable equilibrium. So this is important question for ESC point of view, very important question. Let's try to understand one important topic, that is the last topic of buoyancy and flotation, that is time period of oscillation of floating body. So suppose there is a object which is hanging from the surface, and this is the angle theta. So if we know that F equal to m into a, we know that torque T equal to I into alpha, I equal to we know that I is the moment of inertia, that is mk square, we know that everything. So angular velocity omega, that is equal to d theta by dt, and angular acceleration alpha, that is equal to d2 theta by dg square. Now here, if that is the force, m is the mass, a is the acceleration, t is the torque, I is the moment of inertia, and k is the radius of gyration. So k is the radius of gyration. Now suppose this is the body here, and here there is a one solid surface is there which mass is m, and k is the radius of gyration. Now if you want to calculate the value of I, that is equal to mk square, and the value of t, that is to minus into I into alpha. So minus I into, what is the value of alpha? That is d2 theta upon dt square. So minus I d2 theta upon dt square. Okay. Now here mass on floating body go dotted line to k distance. Okay. Now when mass go at distance k, then the restoring couple created. So restoring couple, we know that the formula wgm tan theta. So as theta is very small, so tan theta will be theta, so wgm into theta. So at equilibrium condition, that is stable condition, that is t, that is equal to wgm theta. So what is the value of t? That is minus I d2 theta upon dt square. So minus I d2 theta upon dt square, that is equal to wgm theta. So from here d2 theta by dt square plus wgm I by I into theta, that is equal to 0. So from here d2 theta by dt square plus mg into w, that is theta mg into gm by mk square. So I, that is equal to mk square, we know that. So I, that is equal to mk square into theta. So from here you can get the omega square, that is equal to gm by k square. So this value is the omega square. So omega square, that is gm into k square. Now from here omega, that is equal to 2 pi n, we know that. Omega square, that is omega, that is equal to 2 pi n, we know that. So 2 pi n, that is equal to under root g into gm into k square divided by k square. So from here frequency, if you want to calculate the frequency n, that is equal to 1 by 2 pi under root g into gm by k square. So here n proportional to under root gm. Now if you want to calculate the time period of oscillation, that is 1 by n, we know that. So that is equal to the inverse of this. So 1 by so 2 pi into under root k square by g into gm. So here we see that t is proportional to 1 by under root gm. So if the gm is increases, this time period, that is decreases. Okay. So if the gm, then the metacentric height is increases. So if the metacentric height is increases, the stability is increases. We know that if the metacentric height is greater than 0, that is a stable equilibrium. So we know that. So if the metacentric height increases, that means the stability increases. So if the stability increases, gm increases. Gm increases means n increases, because n proportional to gm. So n increases, frequency increases, and if n increases, then time period t, that is decreases. So here comfort decreases. So this is very important. Remember this for MCQ point of view. Now for remember this data, this is very important. That is for ore ship, the metacentric height should be 1 meter to 1.8 meter, and for cargos the metacentric height is 0.5 meter to 1 meter. So this is my handwritten notes. You can download it from the description. Like, share and subscribe my YouTube channel. Thank you.